Like most cool things, auroras start with the sun. So the sun's atmosphere, or the corona, is really hot. And because of the intense heat, the hydrogen atoms actually exist as ionized hydrogen, where the proton and the electron are separated. And that is known as plasma. And this plasma constantly escapes the sun because of the intense heat. The particles are moving around so quickly that the sun's gravity can't hold them in, and they blow off the sun in all directions as solar wind. Because of the spin and the charge of these particles coming from the sun, they actually have their own little magnetic fields, and these magnetic fields interact with our Earth's magnetic fields. So Earth is able to redirect most of these particles or the solar wind around our planet. Unfortunately, our noble guardian isn't able to protect us from all solar wind that comes our way. Sometimes solar wind gets stuck. When solar wind is able to make its way into our atmosphere, it can disrupt GPS signals, satellite communications, and even power lines. However, there's one good thing at least about solar winds, which are auroras that they help create. When the particles of the solar wind collide with the molecules in our atmosphere, the particles that were moving super quickly and had tons of energy transfer that energy over to the molecules in the atmosphere, exciting those electrons. And when these electrons fall back to their ground state from their excited state, they release the excess energy as light energy, and that's the identity of the molecule and the energy with which it was hit determines the color that you see. Molecules that help create auroras are usually oxygen, nitrogen, and sometimes hydrogen and helium. The typical green of auroras is created when a particle collides with an oxygen molecule. And even though oxygen isn't the most abundant molecule in the atmosphere, nitrogen is. The reason we see green most commonly is because our eyes are better able to discern green over colors such as blue and purple, which is created by nitrogen. While Earth is one of a kind, it's not the only one with auroras. In fact, Jupiter and Saturn and other planets and some of their moons even have auroras as well. As long as the planet or moon has a dense enough atmosphere, then you will be able to see the light that is created. Even Venus, which has no magnetic field, actually can have auroras as well because it meets the atmosphere requirement. Because there's no magnetic field, the solar wind isn't prevented from entering the atmosphere at most points, so auroras can occur at any latitude on Venus.
So if you ever get a chance to see the gorgeous northern or southern lights, then hopefully you'll know why they occur.